Hey Josh,
Hey James.
I've heard this AI thing's pretty cool and I want to dive in and start learning about it, but I'm a Java developer who has to integrate things into servers and all sorts of different services. This seems like it's going to be hard.
Actually, as a Java developer and a JVM developer, we are uniquely well positioned because 99% of what people are doing when they do AI engineering these days is talking to existing models via REST endpoints. That's integration. And you know what Java is uniquely amazing at?
Integration.
You better believe it. We are well situated in the enterprise. We connect to everything. These Java apps are at the heart of your organization's business logic and the gateways to your data. They are the right place to build this kind of logic.
Okay, so let's dive in and first just walk through how we set up Bedrock so that we can use it from our Spring AI application. I'm in the AWS console and I'm going to go to Amazon Bedrock, and then we're going to be using models.
Yeah.
And there's two different types of models that we're going to be using. One is for our chat, so when we actually have this conversation with the LLM. And so we're going to be using the Nova model for that one, the Nova Pro model. Okay. So we're going to be able to come in here and select Nova Pro, and then I can request access to this model. So this is something that we'll need to do to be able to use this model. So we'll hit that request access, and it'll take a minute for it to enable. You should read the end user license agreement, make sure you're not doing anything against that. But then we're also going to be using an embeddings model, and there's a model here called Cohere. And so we can come down to see all the different models and find the Cohere model and enable the Cohere model for also so that we can do our embeddings, which we're going to do in the application. So there we go. Let's go back to the list, full list here, and we can select embeddings. Oh, there's the Titan embeddings model. We're going to use the Cohere one. So we'll be able to request access to that Cohere model and use that for embedding. So now that we've got everything set up, we'll get our API keys, and we'll be able to then access Bedrock from our application that you're going to build on your machine. So you've already gone through all this and set up your API access keys. And so now we can dive in and start writing some code.
Let's do it. Which brings us to, I think, arguably the most important question, which is, what are we going to build? Everybody loves pets, and it's very relatable, super, super relatable. I love dogs, I love cats, I just don't love my dog. Yeah, no, he's not a good dog. His name is Peanut, and Peanut is a terrible, terrible dog. He kind of reminds me of another dog about which I learned during the pandemic named Prancer. And Prancer, this is this advert that was put on the internet by this woman back in 2021, and she was trying to find a new home for this dog, and she went viral. This thing was on the news, and like it was everywhere. She put out this ad trying to rehouse this dog, and she says, okay, I've tried for the last several months to post this dog for adoption and to make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. But I have to believe there's someone out there for Prancer because I'm tired and so is my family. Anyway, she continues and she says, I was excited to see him come out of his shell and become a real dog. I am convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. So I was thinking, what if we could build something to help people reunite these dogs with their forever home and to sort of help people find the dog of their dreams, or in my case, the dog of my nightmare. So I want to facilitate that process with an AI assistant for our fictitious dog adoption agency called Pooch Palace. Okay? So we're going to go here to start.spring.io. We have some questions that we need to stipulate, or answer rather, before we can proceed. First and foremost is, what is the name of the service? I'm just going to call it adoptions because I'm really good with names. Then we have the choice of what version of Java we want to use.
So we're using Java 23, and we're using the Java language. So now we need to add some dependencies to this thing.
It's going to be a web app, so bring in the web support. We're going to talk to a SQL database containing our data, so we'll bring in Spring Data JDBC. I want to talk to a Postgres database that is also capable of vector store capabilities, right? And we'll talk about that in a second. So I'm going to use PG Vector Store. Okay. There are many different implementations of vector store, of the vector store interface in Spring AI, but this is the one we're using. And then, of course, we need to talk to Bedrock, right?
Yep. So there's two different Bedrock things that you want to add here. So one is for the chat client that we're going to build, and then the other is for the embeddings. And so we're going to bring in both of these dependencies in to talk to Bedrock.
Nice. And it's just already there for you at start.spring.io. And then finally, we're going to, we want to take advantage of MCP,
That's right. We are going to dive into MCP, so that's going to be good. And we're going to bring in the MCP client. We'll build this server later.
Yeah. And then, to make it so I can get live reload, I'll use dev tools.
Great.
All right. I think I'm happy with our selections. Let's hit enter. Open this up in the IDE. It doesn't matter what IDE you use, so long as it supports the version of Maven or Gradle that you've specified, and the version of Java, which all of them will at this point, right?
Yep.
So let's dive right into this. First things first, let's establish connectivity to the data store, right? So we're going to say Spring data source URL JDBC : PostgreSQL localhost my database, okay?
So you've got your Postgres database up and running already,
yeah,
and it's got some pets in it.
It does. Let's go ahead and
Great.
take a look at that. Actually, one thing I like about IntelliJ, click on that little button there, hit test, hit apply, hit OK, go over here, refresh.
Wow.
And
there's our database.
There's our database. There's our dog database. We've got IDs, names, and descriptions. And there's our boy Prancer. His ID is 45. His name is Prancer, and he's described as a demonic, neurotic, man-hating, animal-hating, children-hating dogs that looks like gremlins. So first things first, I think we need to actually establish connectivity to Bedrock. So Bedrock converse chat enabled is true, and then we want chat.options model equals Amazon.Nova.
So this is where we tell it that we're
Pro
going to use the Nova Pro model. So we're going to use Cohere for the embedding. So we enable that.
So now let's build this. Let's actually talk to it. We're going to talk to the data store. We need some types to represent the type in the database. So I'll create a simple entity here to represent that table: string name, string owner, string description. And I'm going to use Java records here. I love Java records. Huge fan, big fan, right? Very, very nice compared to the status quo. And we're using Spring Data JDBC. So I'll say dog repository extends list of CRUD repository, okay? Who's of entity of type dog, whose primary key is of type integer, okay? Integer. So now I think we're good. Let's actually get to the sort of the meat and potatoes here. We're going to build a simple HTTP controller that answers questions for people who are making inquiries as about the dogs in the shelter. Okay, so adoptions assistant controller, right? And let's just try a simple hello world endpoint. We're going to talk to our model via the Spring AI chat client. Okay, I'm being a little tongue-in-cheek here by calling it singularity, but obviously there's no such thing as a singularity just yet. And we're going to say, given a ID for the username maybe, or there you go, user. We're going to have an inquire endpoint, and we're going to return data, okay? We have to configure that chat client. We actually have to have an object of that type configured in the code somewhere, so I'll do that here, and we'll return it, just the default configuration.
So the chat client is what's going to give us access to that model on Bedrock to be able to send prompts and get responses back from the LLM.
Right, yeah. And the first thing we want to do is send the user prompt. Now, a user prompt is the question that the user sends and that you send to the AI model, right? So it'll be specified as a request parameter like that, and we'll send in the user prompt. Oh, I passed in the wrong thing. I passed in the user. Let's try that again.
Okay.
It gave us
the question.
Right.
Yeah, that's
You've got to be sure to pass in the right thing. Do you have any neurotic dogs? Okay. It says, while I don't have personal experiences or pets, I can certainly provide information about neurotic behavior in dogs. All right, so we're going to make this request, and the way we're going to propagate that history, of that chat history, is by configuring an advisor. This is how you intercept requests going to and from a model, okay? And so we're going to configure that here, and we're going to store we're going to cache, we're going to memorize that advisor for each unique user, hence the distinguishing user path variable there. So we'll say private final map string, and it'll be prompt chat memory advisor. Import that, advisors map, and a new concurrent hash map. Advisor map dot compute if absent, passing in the user there. And if the user's there, then we can actually, if it's not there rather, we can create a new in-memory chat advisor. So new in-memory chat, sorry.
The prompt chat memory.
Thank you. There you go. And then passing in the new in-memory chat memory. That's what I was trying to do.
Yep.
Good. So that'll give me back either the existing or a new and then updated advisor. And I'm going to configure that on the call to the model. Okay, like so.
So just add that advisor into the prompt call.
Yeah.
And now we're going to have memory?
Let's try it. What is my name? Your name is Josh.
Great. We've
Okay.
got memory.
Yeah.
Awesome.
Okay, this is good. This is a start because now we can have a conversational experience with our model here. But it's still not giving us, like if we ask that original question, like the original question is, do you have any neurotic dogs? It's still not giving us anything, is it?
It doesn't know about your dogs in your
No.
database. Yeah.
So this is not going to cut it. We have a higher standard of interactions with our customers than this. And so we need to give it what is called a system prompt. A system prompt is a prompt that overrides, it sets the tone and tenor of the responses in governing how we respond to those user prompts. And so I happen to have a system prompt here that I've pre-written, okay? There it is. There's my system prompt. Let's just cat it and I'll copy it to the clipboard. You know what? This doesn't feel right. Let's try that. Much better, okay? There's that, okay?
Oh, you can't cat it, you got to dog it.
Dog it, exactly.
Yeah.
Copy and paste that. And we're going to put that in the default configuration for the chat client. I could also do it here at the call site, right? I could specify it there. But I find it's just one of those things where if you're going to reuse the same chat client for one particular purpose, why not put it here, right? So there we go. And this says you are an AI-powered assistant to help people adopt a dog from the adoption agency named Pooch Palace with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London.
So now every conversation that we have with the LLM is going to have that context in it.
Right. Yeah, exactly. It'll precede everything that comes after it. And so the responses will be in terms of that persona. Okay. So let's try this again. Do you have any neurotic dogs? Okay. Okay. Currently, we don't have any dogs labeled as neurotic in our available listings. However, each dog has its own unique personality, okay, and may exhibit certain quirks.
So we've got our system prompt.
We got a system prompt. It's more in line. It knows what we're doing here. It knows how to play the game, but still, no dice, or in this case, no dog.
Yeah,
right?
no dog.
Yeah. So we need to give it access to our data. And where's our data?
We've got it running locally in our Postgres database.
Exactly. So let's trim this down by sending only the data that might be pertinent to this request. And we can do that by putting it in a vector store. Vector stores support similarity search, semantic similarity searches. And it's not limited to just text. You could put audio and images and whatever, depending on the embeddings and all that. But for our purposes, we're just going to put text, and we want to find things that might be relevant to it. And then from that result, we'll send the sub-selection that comes back from the vector store, and then send that on to the model for further and final analysis. Okay. So let's bootstrap our vector store, okay? Now, I'm using Postgres for my SQL database, and I happen to be using it for the vector store. But there are many other vector stores out there, right?
Different options you can use, yeah.
Yeah, okay. Okay, so let's go ahead and set that up here in the chat client. And in order to do that, I'm going to inject the old dog repository here to get the data from the SQL database. And I'm going to inject the vector store to get the access to the vector store, okay? There are many different implementations of this abstraction available through start.spring.io. We've got 3 on the class path here. Okay, so dog repository.find all for each dog. And we're going to create a document that we're going to write out to the vector store. Now, I'm going to put an arbitrary string, and it doesn't all that much matter what string you put in there so long as it's consistent. So we're going to say dog.id, dog.name, dog.description. And I'm going to say vector store.add list.of document, okay? That looks okay to me. No, wait, I just realized.
Yeah, not.
No, this is much better. There you go, document, okay?
Document.
Exactly.
Yeah.
Now, we have the data in the vector store there, but our chat client doesn't yet know to sort of consult that vector store. So back to the advisors, right? We're going to plug in one more advisor. This time it's just going to be one singleton advisor, and that is the question and answer advisor, okay? Question and answer advisor. This dot question answer advisor equals new question answer advisor, passing in the vector store. Okay. And there's no reason this couldn't have been a bean, for example. I could have had a singleton throughout the entire application. But oh well. Okay, so there we go. One advisor and then the other one, right? This dot question and answer advisor. So now we've got 2 advisors in play, and we're gonna, when the program restarts, it'll write everything to the SQL data store. Do we have a vector store table at the moment? We do not. So here, let's have Postgres and PG Vector in particular initialize the schema for us, okay?
Great. And then we're also going to need to make an embedding streak. Do you want to do that now?
Oh, yeah. Another interesting aspect of what's about to happen here is that we're going to take our text and turn it into a vector, which is a like you remember math, right? Like it's a vector, it's a matrix of number.
yeah.
Yeah, an array of numbers, a matrix. And we need to constrain or define the size of the vector so that both the thing that's going to create the vectors for us, which is the embedding model hosted on Amazon, and the thing that's going to store the vectors, which is our Postgres PG vector implementation, line up, okay?
Yep, we're going to get those to align.
And so we want vector store PG vector dimensions equals, and what do we have here?
1024. Yeah.
Okay, good old
a good
round number. Yeah. Okay, so now, do you have any neurotic dogs? If we've done everything as we expect, it should result in, yes, we do have a neurotic dog available for adoption.
Amazing. So this is called RAG, right?
Right.
We've just done retrieval augmented generation, right? Something like that.
Yeah, exactly.
I get that right? And so we've been able to augment the LLM with some data from our vector store,
Right.
but it found Prancer.
Right, it did. So it's worked. So we found our dog, right? Before we go too much further afield, let's comment out the initialization. I don't want to reinitialize it each time because this takes, it's expensive to do this kind of thing. You might want to do this per request, as you add dogs to the database, you also vectorize the data, right?
Yeah. But we need to figure out how to get this dog a home.
Got to get him a home, right? How do we schedule pickup for him?
Yeah.
And here, this is an example of a system where our model won't have access to the most up-to-date or relevant data. Sometimes that's just a question of how stale is the model, right? Models typically have cutoff dates. They're valid up until a certain point in time, and they know about what's happened in the world up until that point in time. And then after that, you kind of have to plug in the gaps. And then there's also just a question of reach, right? Your model probably doesn't have access to your company's private customer database. That makes sense, right? So we need to give it access to that, or at least to the parts of it that it needs to answer these queries. And we also want to give it access to the real world. So we can do that through tools. Tools are how you give it the ability to ask questions and get responses and do things on its own.
It's like an integration point into the LLM to some other system somewhere else.
Yeah, exactly. The common, most easy to understand example is, how does my model analyze the weather if it doesn't know what the current weather is in my locale, right? Yeah. So you give it a tool saying, hey, give me the weather for this city name, and it'll, given a response from that, it can say, oh, it's raining, you should bring a jacket or something like that.
So in our case, we want to be able to adopt this dog, which means scheduling an appointment, which is going to hook up to our, some business application. And so there's going to be this tool that is going to enable that integration between those.
Right, exactly. So let's build a tool here, okay? Dog adoption scheduler. And we'll have it's going to, schedule dog adoption appointment.
So this is our functionality that is going to be called as part of this request cycle.
And we're going to, let's see, we have to, very important here, right? Remember, you were always taught to be clear and descriptive in your communication. It's all the more important here as a function of your AI engineering skills. So schedule an appointment to adopt a dog at the Pooch Palace Dog Adoption Agency.
So this is important because this is how the LLM is going to decide which tool corresponds to what needs to happen.
Exactly.
And so when you say something around schedule an appointment, it's like, oh, I have a tool that can do that.
Right, and the model will figure it out. So it's actually going to orchestrate the stuff in a sense for us.
So we're putting these descriptions not just on the function name, but also on the function parameters, again, so that the LLM knows how to fill in the parameters in the right places with the right data.
Okay, so here we go. And we're just keep it simple. We're a hard code a response that is, no matter what the date it is today, it'll be 3 days later, right? So we can say you can come on in 3 days from now, right? So there's our instant, and we're gonna just, let's just return a string for that, like that. How about that? Okay, there's the exception. And we're gonna print out, confirming appointment for.
Put in the parameters so we can make sure that this is getting called with the right data that we expect.
Huge. It's going to be huge. I'm just love this part. Okay, so there's that. Let's and now we have to tell our AI, our chat client rather, to take advantage of this tool to make it available in its processing. And the way this works, as you can imagine behind the scenes, is that we're going to make a call to the downstream service. It in turn is going to know about the tools that are available to it. And if it decides it needs one of those, it'll ask us to then invoke it locally and give it the response as required. So here's this. We're going to say scheduler. Just, let me save that to a variable there. Dog adoption scheduler. Okay, add that to the constructor. Got 2 variables there for no reason. Okay, there we go. And now we go back down to tools, and we can just point it to the Spring Bean, right? And then reload. Okay, so do you have any neurotic dogs? So the user is asking if there are any neurotic dogs available for adoption based on the context provided, blah, blah, blah. Prancer with the ID 45 is described. Okay, great. So we clearly found him. So now, next question, which is, when can I schedule an appointment to pick up Prancer at the London location? Okay.
See what happens.
Look at that. It says, based on the tool results, an appointment to pick up Prancer has been scheduled for March 17th. And remember, we said 3 days later. It's the 14th, as you can see up here.
Pi Day, so 3 days after Pi Day.
3 days after Pi Day, very important.
March 17th.
Yeah.
So it called our tool.
And we can confirm as much.
Of course, that could do whatever would be needed in a real backend system, but it actually all worked, and we can see, sure enough, we got the right parameters sent to that function call.
Nice. And this is all local, though. In the enterprise, local is not your friend. Maybe you want to centralize this business logic so that other parts of the ecosystem, the organization, can benefit from that functionality, right? In this case, the scheduling algorithm is it's institutional knowledge. We want that to be reusable for all the AI applications in the organization.
So we got to decompose and pull this tool out from being just built in.
Yeah.
We have to make it a service.
Yeah. If only there was a protocol that could do that.
Only there was a protocol for this. Thankfully, to Anthropic, there's the Model Context Protocol, MCP, which creates this protocol for doing remote tools.
Right. And we've already got the Model Context Protocol client configured here.
We did add that in already.
Right.
Yep.
Before we get to that, let's go ahead and stand up the service so that this thing has something to which to connect. Okay.
So we're going to pull that piece out into its own server.
Right.
Its own MCP server.
So again, I'll call this service. Again, I'm really good with names. Okay. So MCP Model Context Server. We want the web support. Hit enter. I'm going to open this up in the IDE. And this is not hard. We're going to copy and paste, cut and paste even, the logic for the scheduling. So here's our proprietary algorithm for scheduling. Refactoring. Okay, there you go, done. And now we tell Spring AI MCP to export that.
So we've got to wire that MCP server into the Spring Web.
Right. Tool, what is it called?
Callback provider.
Yeah, tool callback. Thank you.
Yeah.
There we go. Okay, and we'll say do that. And we're going to say we want method tool callback provider build, and then here we're going to give it the tool objects. And again, just as before, we're going to point it to our Spring Bean.
Just inject that thing in.
Yep. Okay. And then finally, we want this to run on a separate port since it's not, we don't want it to conflict with the existing port 8081. And now you've got yourself an MCP service. Let's just spin that up.
Amazing.
Amazing. Yeah, not bad at all. Okay, so now we need to build the client side of the coin, right? We've built the service. We need now to tell the adoption service how to connect to our functionality being exposed by that MCP service. So we'll build an MCP sync client, MCP client, and we're going to say MCP client dot sync, passing in the transport. And this is where the rubber meets the road, so to speak. We have to tell it
so with
where
MCP,
to find.
There's 2 default transports that you can use. One is standard I/O, which is great if you're using MCP with the AI code assistant and you can run your servers locally. But for this type of kind of agentic server, we're likely going to have the MCP server running somewhere else, and so we're going to use the server sent events transport for this MCP server.
Absolutely. So we're going to do that. That's the hard part right there, is just making sure you wrote that one little bean that points it to localhost 8081. Okay, and then we'll plug that in just as we did before. Here, MCP sync client, and we're going to point the tools to that. We're going to say new sync MCP tool callback provider, passing in the MCP sync client. Do you have any neurotic dogs?
Let's see. Neurotic dogs. Prancer.
Yeah, there's Prancer. Good. Next question. Natural. Next question. When can I schedule an appointment to pick up Prancer at the London location?
And so now this should be doing the remote MCP call, and
Yep.
Sure enough, it worked.
Yep, the appointment to pick up prancer at the London location has been scheduled for March 17th. We can confirm as much by going over to our service, and there it is.
Great.
Not bad at all, huh?
Nice.
We've done it. We've actually integrated, our MCP service. We built up a brand new AI application. We've used the chat client. We've done system prompts, user prompts. We did RAG. We did all sorts of cool stuff. The last thing, I think, the thing that people might have on the top of mind these days is, how do I do agentic? Agentic just means you let the AI control its own outcomes or its own flow, its own control flow. And that's a very natural thing to do. You can actually have one model talk to another to evaluate the results. You can actually have routing. You can say, okay, the request comes in, we use one model to do very efficient routing and then send it to another for further processing based on a specific set of tools and RAG, okay? Or you could actually even have iterations where one model says, hey, I wrote some code, the other one says, that's good, but you could fix this, and the other one says, okay, I'll fix it, what about that? And you keep going. That's just a while loop, right?
Yeah, that's the way I look at it, is when you go agentic, you're just putting this kind of stuff into a while loop and letting it iterate until it gets to a result.
Yeah.
So you're not defining a static workflow, you're letting the LLM iterate in this loop until it gets to the desired outcome.
And there's two types of agentic systems these days. There's workflows, and then there's like the agentic sort of style, which is you say, here's the end goal and just let it go, which is very hard to get right. Most people aren't doing that. And then there's workflows, which is basically multi-step processes that are mediated by models along the way.
Great.
Either way, it'd be easy to do.
To get to that from where we are here.
Right.
So great. So we've shown kind of end-to-end with Java and Spring AI how to build a AI-powered service, and done the tools, done many different types of integrations with the vector store, with the embeddings, and this was awesome. Super easy. I think any Java developer should be able to do this.
Absolutely.
Thanks for watching.
We hope you got something out of it.
If you liked it, then like and subscribe.
I already did.
You did?
Yeah.
Awesome.
Big fan.
Well, hopefully you will give Spring AI and Bedrock a try, and let us know in the comments how it goes.
And enjoy your journey to production.